Morning everybody. Today we are discussing the next topic of the nuclear chemistry, that is the theory of the radioactive disintegration and modes of decay. This topic is very important and frequently asked university question. This topic is you are already studied in your plus 2 classes, so this is only a revision. So the two of the very famous scientists named the Rutherford and Soddy proposed this radioactive disintegration law, and that is in 1902. So for an radioactive disintegration, there must be a parent isotope, and this parent isotope is an unstable nucleus. For example, uranium, that is an unstable nuclei. Uranium having the unstable nuclei. So due to this instability, they will undergo an excited state, and after that this parent nuclei will eliminate or will emit the alpha or beta radiation, and we will get a daughter isotope, and this daughter isotope are exist in an unstable state. So in order to acquire the stability, this daughter nuclei will eliminate or will emit the beta radiation and to form a stable isotope. So while we are emitting the alpha radiation, we know that the alpha radiation is an alpha helium nuclei, and beta radiation is the flow of the electron, and gamma radiation has no charge. So while we are emitting the alpha radiation, the atomic number of the newly generated nuclei, that is the daughter nuclei, is reduced by the 2, and mass number is reduced by 4. See here, in the daughter nucleus, the parent nucleus is represented by X, having the atomic number Z and mass number A. While we are emitting the alpha particle, the atomic number is reduced by the 2. It is represented by Z minus 2, and at mass number is reduced by the 4, A minus 4, and the daughter nuclei is represented by X dash. So for emitting the beta radiation, the parent nuclei will emit beta radiation, and the daughter nuclei, which is formed having the atomic number one number excess than that of parent nuclei, and there is no change in the mass number. And for gamma radiation, we know that the gamma radiation have no charge, so the atomic number and mass number is retained in that radiation, in that radioactive disintegration. Now we are moving into the some of the example. First is the alpha emission. Consider the example uranium. Uranium is the element, parent nuclei, and having the atomic number 92 and the mass number 238. For an alpha emission, the atomic number, we are already discussed that the parent daughter nuclei having the atomic number 2 number less than that of the parent nuclei. So the newly generated daughter nuclei having the atomic number 90, and the mass number is reduced by the 4. So the mass number is 234, that is the element thorium. The element is determined by the atomic number. Since the daughter nuclei having the atomic number 90, we will get the thorium is the element. And for the beta emission, here we are taking the example as iodine, atomic number 53 and the mass number is 131. So for the beta emission, the atomic number of the daughter element is increased by the 1. So the atomic number of the daughter element is 54, and there is no change in the mass number. So the mass number is retained there, 131. So according to the atomic number 54, the element is Xe, xenon. And here what is the procedure which is taking place in the nucleus is that one of the neutron in the nucleus is converted into proton and electron, and the proton is retained in the nucleus itself, and the electron is emitted as beta ray. So that's why the daughter nuclei having the one atomic number greater than that of the parent nuclei. So next is the beta emission. For the beta emission is occurs due to, for every alpha and beta emission, the daughter nuclei which is formed is an unstable state. So that nuclei will emit the radiation and to acquire the stability. That is the beta gamma emission. Thank you.